So, next thing I want to do to get this guy working is power the motor. This is the PrintShift with this conveyor belt already attached. The conveyor belt should be working. You should make sure your printer is working as well. The printer is built. I did some test prints. Printed this guy. If you got a filament out switch, make sure you test that you run out of filament. But you always want to make sure you're starting from a working printer. Alright. This is the switch that we're going to use to control the motor. When the Z motor, or when I guess the X motor hits this switch on the Z axis, it will run the motor. So we're going to use G code to say, move the bed into the eject position. Alright. Then move the Z axis all the way up to engage and eject your part. This is just a little spacer because I like to run this guy off the motor as opposed to up here. It's just kind of tight in there. Alright, so first thing we're going to do is mount the switch. Then we're going to take some power off of the Mini to the switch. And finally from the Mini to the motor. Also going to be installing a 5-volt USB converter. This is to run a Raspberry Pi later. It just makes sense to put it in now because we're doing all the wiring. This way we don't have to do any extra wiring later. And this guy has just this is a USB Mini B. Micro B? I think it's Micro B. If you're using a Pi 4, just make sure you get the version of this guy that's got the USB-C connector. Alright, so mounting this guy. 2 M3 30mm screws. Go all the way in. And 2 drop-in T-nuts. Just going to use one of these screws and show you how these work. So this can go right into the... This is 30-30, so you need a 30-30 T-nut, not a 20-20 is much more common. But as this is inserted, when you start to screw it, it rotates and grabs the channel. So we're going to use those to install our switch as well as our power converter. The location of these is tight. We have a single column to place all of our gear. But you work it out reasonably. So you can stick those both on, line them up, go out to the channel. And this guy gets mounted right up to the top. It's easy to adjust the position later, so you don't need to worry about getting it exact. As long as it's in the channel, you're good. You can actually hear the click. So that's that. The power converter we're actually going to mount on the side rail down here near the power supply because we're going to mount the Pi back here. You can see it's pretty tight. I did actually mount this is a filament holder. I like my printers to be all-in-one. The only thing this doesn't have or isn't designed for it is a handle. It's pretty hard to pick up when you attach all your stuff to it. But we'll cross that bridge when we come to it. So we're going to install this guy down right about here. Actually, probably the wire's going back because that looks a little nicer. It's the same deal with these guys. See if we can get a good shot of that dropping in. Yeah. Alright, so we want the Pi to have power whenever the machine has power. So we're going to run wires to the Pi, then to the switch, then to the motor. I'm going to run black and red to the motor, so I'm going to put those aside for now. Did bring out another switch just to show how that's connected, but yeah. Next thing we're going to need be using this guy to pull power out of the Prusa. We're going to open up the power supply. Get this wire tucked away. Doing some cable management. Wait till the very end we got everything mounted. But the way I have it set up on the other guy is the Pi facing back here. It seems to work out pretty well. So we need to take off our little crimp. Pop the cover off. You notice we're completely unplugged. This little guy, I'm actually going to use pliers to bend it flat. Let's try that again. For the prototype, I used some very weak crimps. This guy's a good bit stronger. A grounding lug in here, right next to the two positives. So we're actually going to take this screw out. And see the nut we're trying to screw into. Using a different connector. I didn't do a very proper job on the first go round. I'm trying to do this a little bit more robustly. And that's what you get. There we go. You just bend this guy a little more. Make sure you're out of the way. The entire bottom of the board is grounded, so you don't have to worry too much about it. I'm just going to grab my multimeter and make sure that this is going to get 24 volts properly. Fairly certain that it's positive ground. Put her in the right range and you get 24 volts. Can you guys read the meter at all? It says 24. But once we verify that, we're going to unplug this. We don't need to worry about the rest of the Prusa being powered up because I removed the power line. This is a fairly old trick, where instead of using a connector, you just the end of the terminal. There's a hole in the spade lug. You can put your connector through the hole, put on the spade lug. And that will give you a good solid connection with no muss. So now I have 24 volts from the power supply. Green is the ground, yellows are hot. Keep the multimeter handy because I'll probably need to check something else later. But we do not need the power supply in our way. And our wires come out the front, along with the filament sensor connector. The first place we need to get power to is our power converter. And for the ground, we can run all 3 grounds together. For the power, we're going to actually need to cut this guy. Splice it in. Quarter splice, just using an old wire nut. Mainly so that I can come back and replace as needed. You should never need to change out the wires, but pull all 3 wires, make sure your nut is in good and solid. Alright, so power. This is going to clip into a spade lug and then fit into our switch. Apparently you can go too tight on those. And that is going to plug into the common on your switch. Don't actually need any access back there anymore. Common on these switches. What's nice on the back side is you actually have the switch diagram. So it's mounted like there. Common is the outside plug. Normally open is here, normally closed is here. So normally, when the switch is not pressed, there's a circuit from common to normally open. Switch is pressed, it's from common to normally closed. This is power, goes right into common. This USB cable is going to be tucked up here. Just trying to keep things out of the way. That's going up and down, so just going to route this there so that our moving wire is on the outside. I don't need my demo switch. We're already done the crimp on this guy. This goes to the normally closed, or to the, this goes to the normally open, which is the one in the middle. Yes. So we don't want the motor to run until the end stop is triggered. And then this will be soldered to our motor itself. We're going to run the same trick with this guy. And another wire nut to wire up the negative of our power supply. And take that over to the motor itself. So you pull all 3 wires, should have a good solid connection. This can be routed underneath. I'm actually going to plug back in and make sure that we have power. So these are 2 live leads when the switch is connected. Drop this down so I can easily put this with manually. So let's just verify our wiring. We're plugged in. We should get 24 volts. Yeah. 23.9. The other thing I want to check, so this red wire is now not live. The ground is still connected. There's really no way I can hook up to that. Well, you can just grab your Pi and plug her in. See if it boots up a little. Yay. So our converter's working. Motors are plumbed in. And the question is, which direction do we want our motor to go? It's a DC motor, so you could easily switch direction. Now the power supply should have a fuse, so these are not live yet. Only live when this. There you go. Tool I forgot to mention, soldering iron. Mine lives on this bench. That's kind of why I'm here. And part I forgot to mention is, let's get some heat shrink on there. Make it look nice for the internet. I always go through and fold over. Make sure you get a good solid connection. And I guess you could take the motor out or wire it up before installing, but this is easy enough. The case of the motor is usually grounded, so you have to be very careful when you're soldering that you don't connect the case to either of your leads. Not sure of the motor in this case. Always turn off the soldering iron when you're done. Find your heat shrink, get them up. And that is the 100% wiring of this machine. The only other things that are special about it are changing up the G-code to tell it, the printer, when to go where. Do a smidge of wire management. Here I'm just telling all the motors that are coming out of this little power supply to hang out together. Oops, all but one apparently. Whenever you need a zip tie, grab two. So that'll get them out of the way enough for a print test. I'm going to use one of Prusa's original files again. Ooh, filament not detected. Should we load filament now? Print another copy of our microswitch spacer, just because it's fast. I will come back when that is done. We engage the bed. The bed does work. Still good.